Okay. So we're going to do number 12 together. Number 3 has a typo, so fix number 3's typo. There should be no 3 after the NO. Okay. So, like I said, this is probably one of the more complicated things that we've done in this class. But you can get it, you just have to work through the process. Okay, so this is number 12. And number 12 says the Ksp of barium sulfate is 1.1 times 10 to the negative 10. So the Ksp is 1.1 times 10 to the negative 10. Right off the balanced chemical reaction for dissolving. I'm taking you through the steps. Okay, so the steps are realizing that everything in this class is binary. One positive thing, one negative thing. Okay? So barium sulfate solid is going to dissolve into what two things? Barium and sulfate. So the barium sulfate is going to dissolve into the barium 2 plus ion, and that's going to be aqueous, and the sulfate ion, and that's going to be aqueous. Okay. Give me a thumbs up if you're with me so far. Okay, let's just scribble that down. So the first thing you have to realize is the solid barium sulfate will dissolve into a barium ion and a sulfate ion, which I need to give a -2. There we go. One barium, one sulfate. So how are we doing so far? Good. Now, the Ksp equation, all Ksps have the same basic formula. They have the concentration of the cation and the concentration of the anion. Okay. Remember, brackets mean concentration. Concentration of the cation, concentration of the anion. So this Ksp equation is going to be the concentration of the Ba2 plus and the concentration of the SO4 2 minus. That's the basic system. Concentration of the cation, concentration of the anion. That's the solubility expression. Ksp is barium and sulfate. Now we need to use that equilibrium expression to determine how much barium sulfate we can add, or we can dissolve. And to do that, we have to ask ourselves, for every 1 barium sulfate, how many bariums do we get? 1. For every 1 barium sulfate, how many sulfates do we get? 1. So for every X barium sulfate, how many bariums do we get? X. And how many sulfates? X. And then we take these X's and we just plug them into the equilibrium expression. So our Ksp is 1.1 times 10 to the negative 10, which equals X times X, or X squared. That means our X is the square root of 1.1 times 10 to the negative 10. Feel free to do that. Yeah, if you don't have a calculator, get one up. You're going to need a calculator for what we're doing today. Yeah, this is the Ksp equation. All Ksp equations, or Ksp expressions, all have the same form. The concentration of the cation multiplied by the concentration of the anion. And in this case, it's simple. It's 1 cation, 1 anion. After we do this one, we'll take it to level 2 and look where it's not as simple. What'd you get? Yeah, sounds good. So this is X. Because we solve for X, this is X. This is the concentration of each of these ions and the concentration of the solid molecule. Okay? This is X. I mean, there's nothing special. It's X. So when we dissolve it when we dissolve it at saturation, we're going to get 1.5 times to the negative 5 molar solid, 1.5 times to the negative 5 molar cation, 1.5 times to the negative 5 molar. Okay, so far so good? Yeah. So now we need to take this molarity and using our moles over liters, turn that into moles. The good news is we're starting out simple. This is moles over 1 liter. So moles is just going to be 1.05 times 10 to the negative 5 moles of barium sulfate. Okay. Since it's over 1 liter. If it wasn't over 1 liter, we'd have to massage it and do the math to find out what the moles are. Okay, so did a whole bunch of stuff, but we're on the downward trend here. I just want to make sure we're good. Okay. If you understand how this works, this equation, give me a thumbs up. Okay. If you understand where the Ksp equation comes from, give me a thumbs up. Okay. If you understand where the math came from, give me a thumbs up. It's like most of us. Okay. So then you solve for x, and if you understand why this x can be turned into moles, give me a thumbs up. Okay, that's the tricky part. So now that we have moles, it just becomes stoichiometry. So we took our molarity, converted to moles. Now we have 1.05 times 10 to the negative 5 moles of barium sulfate, and we want to convert that into grams of barium sulfate. So for every 1 mole of barium sulfate, we have so many grams of barium sulfate. And that's going to give us our answer. So we take our molarity, use our molarity and our volume to get moles, like we did last month. Take our moles and convert it to grams, and that's our answer.
Wait, I'm sorry. How did you get the 2 plus and 2 minus for the?
Oh, those are just the charges of the sulfate and the barium. Barium is in group 2, so it's plus 2.
Okay.
Sulfate's always minus 2. Okay, so you can handle it from here?
Yes.
All right. Any other questions? Okay, barium sulfate's a pretty simple molecule because it's 1 cation and 1 anion. It's over here. Now in this example, it's not as simple. Okay, so in this example, we have calcium hydroxide. This is number 13 and 15. So with calcium hydroxide, we don't have a simple 1-to-1 ratio. We have something a little more complex. This is number 13 and number 15. I think. Check that. That's right. Okay. Okay. So calcium hydroxide, solid, breaks down into 1 calcium and 2 hydroxides. Cool. So for every X calcium hydroxide, how many calciums do we get? X. But how many hydroxides do we get?
2x.
We get 2X. Okay, because there's twice as much. Give me a thumbs up if that makes sense to you. All right, cool. Now the Ksp still has the same formula. The Ksp still has the formula cation concentration, calcium 2 plus, times anion concentration, hydroxide minus. But there's a big difference. Exactly. The big difference is this 2 needs to turn into a 2 as an exponent over the hydroxide. Because when we take the balanced chemical equation into a Ksp, coefficients become exponents. Yeah?
So if it was like, if there's a 3 in front of the hydroxide, it would just go to 3rd order?
Mm-hmm.
All right.
Exactly right. Excellent question. Okay, so that's where things get a little weird, in that now we have 2 hydroxides. That 2 needs to become an exponent down here. So far, so good? Mm-hmm. Okay. Next, we still bring our x's down, but the calcium hydroxide gets an x. The hydroxide gets a 2x. So the calcium 2 plus is just x. The hydroxide is 2x, and that 2 does not go. That square does not go away. Then the Ksp, when we're solving for our x, becomes x times 2x times 2x, or pretty much the most complicated thing you're going to encounter in this class, that becomes 4x cubed. So when we're solving for our x, instead of Ksp equals x squared, Ksp is going to equal 4x cubed to determine what our x are. Okay. Questions?
So it will be 5.5 times 10 to the negative 6 equals 4 squared r cubed.
Yep. When you're solving for the x, you're going to plug in your Ksp, and then that equals 4x cubed. And remember, how do we do the cube root to get a cube root? Yeah. To get a cube root, just raise it to the 1/3 power. If you need a cube root, you don't have a cube root button, then raise it to the 1/3 power, and that'll give you a cube root. Okay. So if you want to get x alone, take your Ksp, divide by 4, then raise that answer to the 1/3 power, and that's just the same as a cube root.
So you know how in the Ksp for number 12 it was 1.1 times 10 to the negative 10 equals x times x equals x, correct?
Mm-hmm.
You still have to write out, like, when I write out x times 2x squared equals 4x cubed.
I would just, if you want, that's fine. I would put over the Ksp equals 4x cubed, but you can do x times 2x times 2x. It's just, shortcut, I guess. The important thing is being able to solve for x, because the x you get is going to be the amount of calcium hydroxide you can dissolve. Okay. Other questions? All right. So I leave it to you to work on the exercise.